Good afternoon, everyone, and welcome to Safe Products Made Safely, Green Chemistry Tools for Business. And this is our second webinar on hazard assessment tools. I want to welcome you all to our webinar today. I'm Lynn Katz-Cherry, Executive Director of the Great Lakes Green Chemistry Network. And before we get started, I just want to go over a few technical issues with you. You should all have called in on the link that you received, and we want to ask you to call in on a landline, preferably, and not to use speakers and to use your landline telephone to avoid any feedback. However, you will all be on mute for the duration of the call to avoid any problems. And when we get to questions, I'm going to advance the screen. Let's see. My screen is not advancing. I don't know why that is. Well, if you open the little box on the right-hand side of your screen, there's an orange arrow, and you should be able to click open the box on the right-hand side. And on the right-hand side of your screen, you will see that there is a little, there's an area that says questions. I hope you can see it on my screen. But you should be able to see it on your own. And you type in your question right over here where my arrow is pointing, and we will answer all your questions during the question and answer period. And that will be the best way. We will answer as many questions as we have time for. And hopefully, if we don't have time, we will try to reach you afterwards. We'll submit the questions to our speakers and hopefully be able to get back to you with answers later on. We just want to remind you that this session is being recorded and will be posted on our websites, on the Great Lakes Green Chemistry Network website and the Institute for Agriculture and Trade Policy sometime later, probably later in the summer. So I just want to let you know that the Great Lakes Green Chemistry Network is partnering with Kathleen Schuler and the Institute for Agriculture and Trade Policy in hosting this webinar series. The series is part of a Great Lakes Restoration Initiative project to conduct business trainings on green chemistry tools. We are pleased to welcome today's speakers, Lauren Heine and Tommy Thompson. Before I introduce our speakers, I'd also like to thank the webinar series co-sponsors. In addition to the Great Lakes Green Chemistry Network and IATP, the co-sponsors include the American Sustainable Business Council, Clean Production Action, Minnesota Green Chemistry Forum, and New York State Pollution Prevention Institute at Rochester Institute of Technology. We're very fortunate today to have with us two experts in hazard assessment. I want to start by introducing to you Lauren Heine. Lauren is the co-director of Clean Production Action, and she is the director of the Greenscreen program. You can find a much more detailed introduction and biography of Lauren on the website where you registered for this webinar. So I won't take a lot of time going through all of her accomplishments, but I will just tell you that she co-authored the Greenscreen for Safer Chemicals, and she also co-authored the university textbook Introduction to Environmental Engineering, the 3rd edition, into which she integrated sustainability and green design concepts. She has co-authored a number of other articles and had served on a number of different panels and has a number of accomplishments in terms of sustainability and green chemistry efforts. So right now, I'm going to turn this over to Lauren, to turn the screen over to Lauren to begin her presentation.
Thank you very much, Lynn, and thank you for having me. It's a pleasure to be part of your good work in the Great Lakes region. Lynn and Kathleen asked me to speak about today the green screen for safer chemicals. Here we go. And we'll have lots of opportunity for questions as well. So the green screen is a method for chemical hazard assessment developed by Clean Production Action, a nonprofit organization committed to green chemistry and sustainable materials. It supports the 12 principles of green chemistry, and it builds on US EPA Design for the Environment criteria and other national and international precedents, such as the globally harmonized system of classification and labeling of chemicals and OECD. The intent was not to reinvent the wheel when it comes to hazard identification and classification, but rather build on it and create an information system. And importantly, the green screen is open, transparent, freely accessible, and peer-reviewed. You can go to our website, link at the bottom, and download all of the method documents and guidance and other information. And it supports green chemistry because by definition, green chemistry is the design of products and processes that reduce or eliminate the use and generation of hazardous substances. And there are 5 principles of the 12 green chemistry principles that deal directly with reduced hazard, whether it's making less hazardous chemicals, using less hazardous reagents and solvents, designing chemicals to degrade, and minimizing the potential for accidents from explosions and things like that. So there are two tools that have evolved from the green screen method. The first is the full green screen, and that's a systematic evaluation of chemicals based on 18 different hazard endpoints like cancer, fate, aquatic tox. It provides a standard hazard assessment format and identifies inherently safer chemicals. To use the full green screen, it really does require a level of technical expertise, and if your organization does not have that level of expertise, then it's probably best to use the licensed green screen profiler, and I'll talk a little more about that later. The other tool that's come out of the green screen is called the Green Screen List Translator. I call this a kind of quick and dirty green screen. It helps to identify known hazards. It takes the authoritative list part of green screen. Green screen itself is much more than hazard lists, but it does build on certain hazard lists. And so what it does is it automates those lists. So you can plug in a chemical identification number, CAS number, search hundreds of lists, and then it maps the presence of a chemical on certain lists to hazard levels. It doesn't really require any toxicology expertise, but the best part is it's automated, so you can do in about 2 seconds what would take many, many hours otherwise. But the list translator it maps chemicals on the green screen specified list to green screen criteria and scores. It's really good at identifying known bad actor chemicals using authoritative and screening lists. It can provide a really great sandbox. If you're considering a formulation, you could use List Translator and see what's already known about this chemical. Is it on endocrine disruptor lists or EU hazard phrases and things like that? And it's always nice to have the option to use software to expedite this. Our 2 List Translator partners are the Pharos Chemical and Material Library, and Pharos has 2 databases right now. One is called the Building Product Library, and that's the one I think most people are familiar with. But the building product library is based in part on their chemical and material library. And that is a library that just allows you to plug in a CAS number and search lists. And the lists in Pharos are based on Greenscreen List Translator. The other software partner we have is the Works. They're a for-profit company. They have a tool called GreenWorks, and they have a rather elegant version of Greenscreen List Translator where you can plug in any number of chemicals and get a printout of the report, and wherever there is a hazard list, so each of these blocks is a hazard endpoint. I don't know, I hope you can see my cursor here. And if a hazard, for example, is on a cancer list, it'll be in the cancer column, and it will say high, medium, low, and if you click on that cell, it'll tell you what list it's on for cancer. If a chemical is not on a list, then it just leaves a blank. And that's why List Translator is kind of a quick and dirty tool. It's not a good tool for telling you if something is a greener chemical, but it can tell you if something is known to be problematic. And it's a good first step. If you see a chemical that has absolutely no hazard flags in the row, then two things could happen. Either that's a really benign chemical and you should do a full green screen to confirm that, or very little is known about that chemical, and that's why there's no data there. So that's why List Translator is just a good first step. List Translator does not include a full assessment of data. It does not represent a comprehensive review. It does not consider transformation products. It does not identify safer chemicals. To really be confident that an alternative is safer, you should perform the full green screen assessment. Full green screen assessment is valuable because it uses all available data, not just lists, but scientific literature, test data, analogs, read across, QSAR models, and it will increase the confidence in results, help you identify truly safer alternatives, not just the chemicals of concern. And it also helps you to know what you know and what you don't know. You can know the hazards, but you also know where there are no data. That's important too, because depending on your application, you may need to gather data for certain endpoints. For example, if you're making a skincare product, you wouldn't want to use a chemical that doesn't have any dermal sensitization or irritation data, that sort of thing. So to do the actual green screen assessment, there are 3 steps. The first step is to assess and classify the hazards. The second step is to apply the benchmarks, and the third step is to use that information to make informed decisions. And I'll talk about each one of these steps. So these are the 18 hazard endpoints. There's the group 1 endpoints like carcinogenicity, mutagenicity, repro, developmental toxicity, endocrine activity. Then the group 2 health effects. These are more potency-based. And the environmental toxicity and fate, and then physical hazards, including flammability and reactivity. And for each and every one of those endpoints, there are a set of hazard classification criteria. And wherever possible, we rely on GHS to help us with the classification, because it doesn't make sense to reinvent hazard classification. So to classify something under GHS, you would need to do the research and to determine whether the chemical is known or presumed as a carcinogen using GHS criteria. So if you do the research and decide it's a category 1A chemical, then that would be high for the green screen. Likewise, if it was a category 2, it would be moderate. And if you see that it's negative, which means that there's sufficient data and there are negative studies saying this chemical is not carcinogenic and there are no structural alerts, then you would call it low. Some of these endpoints, not all of them, but some of them are supplemented with hazard lists to expedite this. So for the carcinogenicity endpoint, there are actually quite a few national and international lists you can use. So for example, if something is on the IARC list and it's a group 1 or 2A, then you can call that up high for cancer, and it's these lists only that are plugged into the list translator, and that's why it's a nice shortcut. So after you do all the research, for example, you search the literature, if you don't find anything there, you might do some modeling. You don't find something there, you might look at an analog and see if you can use data on a chemical analog to get a hazard classification. And then you try to populate this, what we call this hazard table. And again, here are the group 1 endpoints, group 2, ecotox, fate, and physical chemical properties. And this probably would be very unusual to have every cell filled. Very often you get a data gap because if you can't find any data anywhere, you can't model it, then you have to put data gap. Also, we use a convention of where there's a bold letter. That means that it's based on test data and higher confidence. Where there's an italic letter, that means it's based on models or screening assays or something that would give you lower confidence. So you can look at this table and know a whole lot about the hazard profile of this chemical. But what happens at this point is maybe you have 2 different chemicals with, and neither of them are green across the board, and you're saying, well, how do I know which one is better? What do I do with these endpoints? Which endpoints are more important? Are there combinations of endpoints? And that's what leads you to step 2, which is the benchmarks. And the benchmarks, you start are a way of applying a subjective screen to the hazard profile that you just generated. And so what we did to develop the benchmarks is to align what we call benchmark 1 with regulatory drivers. So we looked at U.S. policy, we looked at REACH. When I say the original report was done by myself and Mark Rossi. That was the early report. And then we looked at Canadian priorities, and we said, what kinds of chemicals are governments flagging as chemicals of high concern? And typically those are PBTs, persistent bioaccumulative toxic, VPBBs, very persistent, very bioaccumulating, very toxic for cancer, mutagen, reprodevelopmental, endocrine activity. And in Canada, they also flag like very persistent and toxic and very bioaccumulative and toxic. So we basically said, this part is subjective. Let's go with national and international values here. And so what you do is you look at that hazard profile and you say, okay, is this chemical high for persistence and high for bioaccumulation and high for these toxicity endpoints? And so in this case, you would look at this chemical and say, nope, it's not, because it's very low for persistence and very low for bioaccumulation. Then you would say, okay, well, is that true? No. Is that true? No. Is it high for any of the group 1 endpoints? And you'd say, nope, it's not. So you'd go through this. If any of these are true, you would say, stop, this is a benchmark 1 chemical. If none of these are true, you move up to the next algorithm and ask the same question. Is it moderate for P, moderate for B, moderate for T, etc.? And is it moderate for any of the group 1 endpoints? And in this case, you would say, yes, it is for developmental and endocrine activity. So you would say, okay, this is a benchmark 2 chemical. And so that's how it works. You just you keep going through these questions, and if you get up to benchmark 4, then it's going to be a low hazard across the board. And if you read the guidance, which is available on the website, you can download, then sometimes certain data gaps result in a benchmark U, which means you don't have enough information to make the classification. So if you know something as a high hazard, you can do that with very little data and call it a benchmark 1. But to call something really benign, you have to have a very complete data set. So then you get to step 3, and step 3 is making informed decisions. And while at first, to me, as a environmental chemist / engineer, I thought, oh gosh, rolling all this up into 1 through 4, that seems so simplistic. But it actually was really one of the more valuable parts of the Greenscreen, because not everybody, most people aren't experts in toxicology and need a shorthand way of choosing chemicals, whether it's for procurement or for product design. And so you can say, okay, well, try to avoid benchmark 1 chemicals. Avoid them, phase them out. Benchmark 2, you can still do better. You're going to have to manage it, though, because they have certain hazards. Benchmark 3, you're really getting there. Benchmark 4, etc. So it really, it's a nice, presents a nice, simple way to talk about chemicals. And you can always refer back to the hazard table and refer back to the report that supports the hazard table. So you can go as deep as you want, or you can just roll up to a benchmark score. So we're seeing lots of applications for Greenscreen, which is really interesting to see how it's being used. One way is as a support for alternatives assessment. The Interstate Chemicals Clearinghouse recently completed their alternatives assessment guidance, and it's broken into modules. And the hazard module is based primarily on Greenscreen. And Greenscreen is part of regulations in Maine looking at alternative chemicals to chemicals of concern in children's products. I'm confident that it will be a useful tool for California, although California won't mandate any specific tool. It's being used for materials procurement to identify chemicals of concern, safer alternatives. It's being used in product development. I've seen some really nice work of people using this internally to evaluate new chemicals and new formulations. It's being written into corporate policies to see companies like Staples who are looking for disclosure of benchmark 1 chemicals and are looking to clean their product inventories. And it's increasingly being seen as a normative reference in various standard scorecards and eco-labels, and I'll talk about that a little more, but it's cited in you get 2 credits in USGBC's LEAD version 4, and there we have a memorandum of understanding with Cradle to Cradle certification. So here, I'll give you a couple of examples of how it's being used. Hewlett-Packard is a leading user of Greenscreen. Whenever they are replacing a chemical of concern in their products, they require their suppliers to use the Greenscreen to provide information on the alternatives. They don't want to replace a regulated chemical of concern with an unregulated chemical of concern that could end up becoming regulated. So their goal is to choose better materials. Replacing materials is expensive. They've told us that it can take cost $5 to $50 million to pull a chemical out of their entire supply chain. So they want to select something that won't be restricted in the future. And so they look for replacements that have a lower environmental impact. They want to avoid unintended consequences and choose things that are really preferable, not just minimally acceptable, not just legal. They want things that are really better. So what they do is they say, okay, let's say they're looking for an alternative flame retardant. They do an assessment of the alternatives that could be viable for their product, and they identify which ones are, say, benchmark 1s, benchmark 2s, benchmark 3s, benchmark 4s, and they actually consider designing out and the need for no flame retardant at all is a benchmark 4 in their system. And so they select things that won't be restricted in the future. But they use this tool, the Greenscreen, to tell their suppliers what they're looking for. So they tell their suppliers, we're not just going to say we don't want X or we don't want Y. We want to say what we do want. And so it's nice because the suppliers now have a tool they can use to say, you know, is this chemical a PBT? Is it a VPVB? Whatever. They can use the Greenscreen themselves and make sure they're not trying that their chemical has better attributes before they even bring it to a big OEM like HP. So what HP did, one of the first materials they sought to replace were PVC wire and cable. They made screening mandatory. They had full disclosure of the alternatives that their suppliers made under a confidential agreement. They screened over 30 materials. Several of them were approved, and they're now on the HP approved materials list. And in an ongoing way, what they're doing is they're bringing more material types into their program, solders and cleaners and things like that. They're promoting Greenscreen within the electronics industry and to formulators. They're helping to incorporate it into eco-labels and helping with the infrastructure to enable screening and sharing of Greenscreen results, and I'll talk a little bit more about that. The other big example of how Greenscreen is being used is as a source of 2 credits in the new U.S. Green Building Council LEED version 4. There's 2 parts to this this standard. There's the material ingredient reporting credit, and there's a material ingredient optimization credit. And so there's 2 parts, the 2 credits, and they're a little different. If for the reporting credit, you would look at 20 different products, and you would screen those products and report ingredients at a threshold of 1,000 parts per million. For the optimization credit, which I'll explain a little bit more, you would look at 25% of the permanently installed products by cost. So you look at actually a potentially different product set, and you would have to inventory those products to 100 parts per million. So that's a very challenging threshold for a lot of manufacturers. It's very ambitious, but you would earn a whole of 100 points. These are 2 of 100 points, so they can be valuable in the LEED system. So the 2 credits are designed to promote a roadmap to optimize products. So the first question is, what's inside the product? That's where the inventory requirement comes from. And then the first level of screening is to say, is it a listed hazard? Is it known to be hazardous? Then you could go deeper into it and try to understand what are the nature of the hazards, of all the hazards in a more comprehensive way. And then you can look at other product impacts. So that's the flow from inventory to assessment to optimization. And so the tools that support this are also aligned. We have the Health Product Declaration, which is an open standard. You can go to Health Product Declaration Collaborative and use that as a way of reporting your inventory. And if you want that first credit, you would have to report to 1,000 parts per million. HPD allows for protection of trade secret information. You can do it yourself. And the Pharos has what's called the HPD Builder, so you can do this online. You can generate an HPD online powered by Pharos. The next step is the ingredient hazard list screening, and you can do that with HPD also. If you use the HPD Builder with Pharos, it automatically screens hazard lists, which happen to be the same lists as list translators. So they have integrated the Greenscreen list translator into the HPD Builder tool. And what's nice about this is that you can do all of this yourself. It could be self-reported, and you can do it as a sandbox yourself, or you could engage a third party if you want. But these tools are all freely and publicly available. If you want to go deeper, though, you need to dive deeper into an ingredient hazard assessment. This is where you would use the full Greenscreen assessment, but also in the LEED standard, you can use cradle-to-cradle certification. And cradle-to-cradle goes further than hazard assessment. It also includes renewable energy, social metrics, water, and cyclability. And so that really is a more product level assessment. And to do either of these, a full Greenscreen or the full cradle-to-cradle certification, you would need to engage either a Greenscreen profiler or this a cradle-to-cradle assessor. But you can earn both points. There are ways to earn both points, even just doing it yourself. But what I wanted to share too is that it was valuable to USGBC to encourage harmonization of these tools. So the idea that Pharos built the HPD Builder, which uses the list translator, which supports the full green screen, and we have a memorandum of understanding with the Cradle to Cradle Institute, so that if someone has a green screen assessment of the chemicals in their products, they can take that assessment and use it towards Cradle to Cradle certification, which can drop the cost of the assessment work. So that's a nice loop, because you can do a assessment of your chemicals and decide if you think you're a good candidate for this eco-label certification. So you can see you can do this in a progressive way over time. So if you're interested in learning to having assessments done and you don't have the interest or capacity in-house, you can go to, we have 3 really great profilers. There's Talk Services, NSF International, and Cyvera. Their contact information is here, also on our website. We provide training. We have 2 trainings coming up as part of the Great Lakes Restoration Initiative. And one is in Cleveland on April 3rd. One is in Buffalo on June 4th. Those will be the last of the EPA-sponsored workshops. The sponsorship helps us keep the costs very, very low, basically lunch plus the cost is a little more than lunch and some of the other costs that EPA doesn't cover. We can also do customized training in person or online. And we have a certified practitioner program, which is really interesting, which I'll talk to you a little about. And if you have interest, you can just go to our website and sign up for announcements and things like that. But the certified practitioner program is designed to train people really in depth in the method. And this is for people who are professional toxicologists or professional EH&S people within their organizations who want to really dig deep. The one-day workshop is fine, but you can only do so much in a day. And this is you need to have the equivalent of the one-day workshop or some experience with Greenscreen to take it, and you need to have a background that that will allow you to go deeper. We do this through 4 live 3-hour classes, and then there's a practicum, and each participant does 2 Greenscreen assessments, and it's done with coaching and evaluation. So you start out doing it as a group. Each person does their own assessment, and you do the group 1 endpoints, and you get feedback, and then group 2 get feedback, and the benchmarking get feedback. And then the second, and it's quite a bit of work. And then the second one you do on your own, and then also get feedback. So we just opened registration, and if anyone's interested, please just go to the website. And what's interesting about, I'll talk a little bit about this, but the Certified Practitioner Program is linked to the verification program, and we've developed a verification program because sometimes people want an extra level of quality control. We don't know if people will actually be interested in making public claims, but the way we set up Greenscreen, anybody can use it for internal purposes, whatever you want. But if you're going to make some sort of product claim, the only tool we have to sort of protect the integrity of the tool is our trademark. And so you can't use the Greenscreen trademark on a product. But if you wanted to go through a verification program, then there could be an opportunity to license the use of the trademark on a particular product. So if somebody wanted to say, my product contains nothing but benchmark 3 chemicals, they could potentially do that. Or if they just want an extra level of oversight to make sure that the quality of the assessment is as good as it can possibly be, that's what verification is about. But typically, the only assessments that can be verified are those that are done by Greenscreen profilers. But if someone takes the Certified Practitioner program and becomes a Certified Practitioner, then they too would be eligible to submit chemicals through verification. And the reason is that we want to make sure that before we take the time and energy to verify things, that people actually know what they're doing. They understand the method, they understand the rules. So we're excited about this new program. And the other thing, which I think is kind of the holy grail for us right now, is can we build repositories where green screen assessments can be held and shared either freely or inexpensively. And there's one effort to do that right now that's up and running, and that is the Interstate Chemicals Clearinghouse. It's the group of 10 states, and they have built a web-based portal. It's very new, and there are very few green screen assessments in it right now, and also what are called QCAT assessments, which is like an abbreviated green screen developed by Washington Ecology and based on green screen. So you can go to this database, you can look up a chemical CAS number, and then it'll show you the hazard table for that chemical. Here's diiron trioxide, and then there's a link to the full green screen assessment, which they're often anywhere from 10 to 25 pages long, so you can just download that assessment there. So the states have the ambition to grow this database. They are freely available. It's a little challenging to get people to buy a green screen assessment by a profiler because they take a lot of professional time and then just give them away. But we think that this will be a good, but that may be something that states can chip in on, or other consortia might find value in sharing assessments in a publicly vetted space. So I will just mention one more tool. This is kind of fun. This was developed by Talk Services, one of the profilers. They created a tool called Greenscreen Inspector, which allows you to, just use the drop-down windows and put whatever hazard classification you get for a chemical, and it will automatically calculate the benchmark score. And that's kind of nice. It's a really good way to check yourself. Rather than going through the algorithm, you can actually just use this tool on the Talk Services website, and that tool is freely available. But of course, you have to have the hazard classification information to use it. But it really is a neat tool, and there's a little video on it on Talk Services website. So I'm going to wrap up now and just say the green screen is open, transparent method for chemical hazard assessment. It seems to have all sorts of uses and applications. And this quote, I think, really describes in my mind the value of it. The more you know about what you're putting into your products, the more likely you are to make better choices in product development. And this was Jonathan Plisco, who works for Poly1, said this. This is not intended to be an endorsement by Poly1 by any means, but it was. I have permission to use this quote by Jonathan because I just think it really speaks well to the value of the green screen tool. So there's my contact information. We'd be happy to answer any questions and turn this back to Lynn.
Thank you so much, Lauren. That was really interesting. And we will hold questions until after Tommy's presentation. So right now, and I want to remind you, you can ask your questions anytime during the presentation. You don't have to wait until the end of the presentation to post your questions because we'll be keeping track of them. So now I have the great pleasure of introducing Tommy Thompson. He is the Senior Manager of International Environmental Affairs for Heine Brands Incorporated, and he has been working in the environmental field for over 36 years as a regulator, consultant, chemical project engineer, and head of corporate environmental affairs. His responsibilities for Heine Brands Incorporated cover all aspects of global environmental compliance and management for the corporation, including regulatory compliance, auditing, corporate policies, environmental management systems, and a robust chemical management program that was initiated in 1991. So I think we're very fortunate to have him today to give us his overview of the Chemicals Management Working Group and the Chemicals Management Module and the work that's being done by the Outdoor Industry Association, who has put together a a tool of their own. So with great pleasure, I'm going to turn it over to Tommy Thompson. Thank you, Tommy, for being with us today.
Thank you, and good afternoon, everybody. The topic that I'm presenting on today is actually the Outdoor Industry Association's effort to create a chemicals management module. And unlike the Greenscreen, this is not a tool for evaluating chemicals per se. It's more of a framework for being able to determine what you need to do to develop a chemical management system. And bear with me, all of a sudden my computer has locked up. Here we go. So our goals for today, we want to inform you about the Chemical Management Working Group and the Chemicals Management Module. I'd really like to encourage you to review this module, and we'll give you the website for it at the end today, and take a look at this. And you'll understand more, and I'll explain why we think this is such a valuable tool as we get to the end of this thing. And we will be answering questions. I'm also going to give you a peek into what we do here at Hanes Brands with regards to chemical management, because we do get a lot of questions with regards to our program, especially since it's been in existence for so long now. The mission of the Chemical Management Working Group, and I'm not going to read this, I'll let you take a look at it. It is continuous improvement. And the Chemical Management Working Group's envisioned future statement really is to spread the knowledge, the integration of this into other chemical management programs, and to develop a community of practice. This is the current chemicals management community of practice that has been involved in this. And I'm going to stop just a second and talk about the Outdoor Industry Association and how this came about. The Outdoor Industry Association, I was really an outsider looking in, not part of this organization. And prior to my involvement, they developed the HAGUE Index, which is, in my terms, somewhat of an environmental auditing system. If you look at the primary members of the Outdoor Industry Association, it's primarily retailers. And what they were looking to do was to develop some method for being able to develop sustainability programs that they could use as their programs, but they needed to be able to bring in the manufacturers and brands that were producing products for the retail stores themselves. Now, the Outdoor Industry Association developed this HAGUE Index, and then in coordination with the Sustainable Apparel Coalition, they began to work together. And the Sustainable Apparel Coalition took over the Outdoor Industry Association's HAGUE Index. And at that point in time, the Outdoor Industry Association began to work on this idea of a chemical management working group. Now, this is a busy slide, and I'm going to very quickly talk to basically what this is telling you. The Outdoor Industry Association and their membership decided they were going to address chemical management, and they wanted to come up with a framework. They opened it up to their membership, and my recollection is they had over 100 organizations that wanted to be involved in the development of this tool. The challenge was very few of those organizations had any expertise whatsoever. So they decided to narrow it down to what they called their small working group. It was still about 30 people / organizations, and they still had the same problem. The amount of expertise was not there, at which point they narrowed it even further to just a few core people that had been involved in this or were working already to develop chemical management systems that could be used to drive manufacturing towards more sustainable chemistries. The result of that was, in 2013, the first version of the chemical management module was launched. There was a beta test on it. The chemical management module was, from the outset, intended to be incorporated into the Sustainable Apparel Coalition's HAGUE Index. The HAGUE Index was updated to version 2.0 in November of this year, and in fact, they began to incorporate the chemical management module into the HAGUE Index. Now, I say they began to because they did not incorporate the whole module. It is a very complex program, And consequently, what they wanted to do is begin to initiate it slowly to get it started with the intent of beginning to work towards adoption of the complete module. You'll also notice on the slide for 2014 what is being planned. I can tell you that for the Outdoor Industry Association, one of the big things is they're going to have to get more adoption of the chemical management module. That's going to require more training. We already are getting requests to put this into multiple languages, and there is a very high level effort between the Outdoor Industry Association and the Zero Discharge of Hazardous Chemicals group to be able to coordinate efforts in driving towards more sustainable chemistries. The collaboration with the Zero Discharge Hazardous Chemicals Working Group, that organization itself has got a number of initiatives. These are highlighted here. These are the ones where the Outdoor Industry Association is working in coordination with the ZDHC to try to drive towards more sustainable chemistry. And one of the things that is interesting here is that now the Zero Discharge of Hazardous Chemicals Working Group has also determined that they need to come up with an auditing program to be able to get out into the field to look at not just environmental performance, but begin to audit chemicals in use as well. The key facts about the chemical management module. It was originally intended to strengthen the Sustainable Apparel Coalition HAGUE Index and be a portion of that. One of the things that is key to understand is that this is not a program that's going to be a tool for getting you recommendations for more sustainable chemistries. Instead, this is a tool to help you establish the management system to get you working in the direction of having programs to understand how to get to the point that you can identify those sustainable chemistries. It is intended to be flexible. There will be more revisions to this over time. It will evolve. It is based on global applicability, so it's not just for one locale. It's something that can be used universally. It's not an Outdoor Industry Association tool. It is a combined effort with the Outdoor Industry Association, the Sustainable Apparel Coalition, and as I referenced earlier, the ZDHC is also combined in this effort. This is the group that I refer to as the small group. And when you delve down into this, there are actually very few participants of the Outdoor Industry Association. The reason for that, again, is the Outdoor Industry Association is primarily retailers that did not have the expertise in chemical management, but they were looking for that expertise. It took this group, by my estimate, about 18 months to develop a tool that I'm going to show you. Now this is a snapshot of the opening page of the chemical management module. If you look across here, you're going to see CM 1.0. This is the very first objective out of 7. The other thing that is interesting to notice is you're going to see categories for retailers, brands, suppliers, and chemical suppliers. So we have developed indicators, if you will, for each of these categories. To the left, you're going to see these dots, and underneath it is going to be F, P, and A. F stands for foundational, P stands for progressive, and A stands for aspirational. So in this very first objective, which is regulatory awareness and compliance, there are a number of indicators for each category, retailer, brand, supplier, and chemical supplier, for them to be able to follow to progress their chemical management program. Now it's very easy. I can tell you that virtually every one of these objectives, the very first indicator is name somebody in your organization that's going to be your contact and your chemical expert. It's foundational. That's how you get started. You do not have to go through and complete every one of the indicators in an objective. It's set up so that you can go at your own pace and address those objectives and indicators that are most appropriate to your program. The other thing to realize is that these indicators are progressive, meaning that more than likely, if you are a brand and you have completed B.1.2, more than likely the ones above it you've already accomplished as well. Not always, but that's typically the case. So now what are the primary objectives? The primary objectives: first, regulatory awareness and compliance. Second, restricted substances and substances of concern. Third, process and product chemical knowledge. Number 4, chemical hazard assessment. Number 5, chemical safety and risk management. Number 6, safer alternatives assessment and preferred chemicals. 7, sustainable chemical innovation and continuous improvement. And if you look at this, you can see if you're looking at a chemical management system, you would start with regulatory awareness to understand what is applicable to your manufacturing or your product, and you would want to progress in this direction to accomplish more sustainable chemistries. This is a slide that basically summarizes what these objectives were. You start off with the process and product chemical knowledge. You look at the regulatory awareness to make sure you know what may be applied to your chemicals in use. You do your chemical hazard assessment by looking at the chemical safety and risk management, looking at the restricted substance of concern, looking at the safer alternatives. If you need to, you start back at the beginning, go back to your chemical knowledge. If you have gotten to the point that you have identified safer alternatives, then you begin to do sustainable chemistry innovation and more continuous improvement. So this is an evolving program that never ends. You continue to progress. Which brings me back to what this document looks like at the very beginning. Again, it is to be progressive so that you can work through it at your own pace and determine what is most appropriate to your company. Now, in addition to that, there is a scoring tool that is available where you can go in and you can evaluate your program to come up with a score to see how you're performing overall with regards to the chemical management module. Now, incorporation into the HAGUE Index. The HAGUE Index is part of the Sustainable Apparel Coalition's effort to come up with a unified tool adopted globally to be able to document sustainability at the manufacturing facilities. It also has a brand module and it also has a product module. As part of the HAGUE Index, the chemical module of the OIA is being incorporated into that to be able to provide a scoring mechanism and a guidance for being able to develop, by the original intent, a chemical management program to help companies manage their chemistry and evolve towards more sustainable chemistries. In that mechanism, as part of the HAGUE Index, in the brand, there is a product module, and in that product module, it is incorporated where there are metrics. You can look at your water use, your wastewater, energy, other environmental impacts, but this is where the chemical module is also going to be embedded. There is a product module that actually evaluates the product by looking at the raw materials that go into that. A key part of that, not shown here, is that Nike developed what's called the Material Sustainability Index. That Sustainability Index is a tool that they have developed to document the environmental and health impacts of the various types of fibers that might go into apparel. So that is incorporated in here to try to not just look at chemistry, but look at the finished product and what the overall impacts would be of that finished product. So again, the chemical management module was incorporated into the HAGUE Index in November of this past year. It was released in December of this year. It is in the early stages. With the next upgrade of the HAGUE Index, you will see more of the incorporation of the chemical management module. The next steps for the chemical management module, from my perspective, a key part again is adoption, spreading the word and getting more people to use this tool, education as to what this tool is about, and the combined efforts with the Sustainable Apparel Coalition and the Zero Discharge of Hazardous Chemicals Working Group to work together to begin to focus more on driving the industry towards more sustainable chemistries. Until this point in time, the primary focus of this industry has been to comply with regulatory requirements. We're trying to move the ball so that people are now looking at more sustainable chemistries. Which brings me back to this group, and I'm going to make sort of a broad statement. The Outdoor Industry Association, from my involvement with them, has done an admirable job of developing this tool and pulling the resources together to do it. I've been in the environmental field a long time, and my approach to environmental compliance is I can minimize my environmental footprint and make safer products if I look at the raw materials that I'm using. And that's been the mechanism and the guidance that I've been giving this corporation since I came on board in 1990. I joke with people, I tend to be a lazy person. I try to find the ways that will avoid me having to do more work. And if I can find ways that we are protecting the environment and protecting our consumer, that's going to make my job a whole lot easier. I have a lot of people asking me, how did you do it? What are you doing? How can we do it? And this tool answers those questions. Again, it is a step-by-step progression of how to initiate and develop a chemical management system to be able to develop products that are more sustainable, as well as have manufacturing processes that are more protective of the environment. Now I'm going to progress or digress a little bit, however you want to look at it. Again, a lot of times people ask us about our chemical management system, and I'm just going to give you a quick peek into it. The apparel industry is a tough industry to be in. It's typically a lot of mom and pop operations, low income, tight profit margins. When you go to apparel companies, it's rare that you find any chemical expertise on staff. They have virtually nobody to refer to. They also rarely have any trained environmental professionals. Consequently, what they do is they rely on their chemical suppliers for the technical knowledge of the chemicals that they use, which leads me to the third bullet. Especially in today's global market, the chemical suppliers are blending houses, and they themselves do not understand the chemicals that they're putting on the market. It is a huge problem. Published technical chemical data is very limited, and the data sheets are grossly ineffective. And again, you add into that the global economy. It is just a system that is really broken, that needs improvement. And then the last one I'm going to touch about briefly so you'll understand is industry economics. And when I say this, people are astounded. In our field or in our business, if one of our suppliers increases the price of their garment by 1/10 of a penny, more than likely they've lost the business. So it's extremely competitive. And consequently, they're always looking for ways to save money, which means they're looking for ways to cut corners, which means they're looking for chemicals that might be less expensive. And because they're less expensive, there may be more impurities and more chemical problems with regards to those raw materials. The major challenges for us, the global supply chain is becoming more and more of a challenge. The language barriers, cultural differences. The big one that I'm going to highlight here is chemical supplier expertise. It is a real challenge. We've got some of the major international companies that really know their stuff, but I can also tell you that even within those organizations, there are many times that they have chemicals that they put on the market to which they cannot answer the next question. Where did the feedstocks come from and what's in them? They really don't know. The regulatory explosion is really hitting hard with regards to all the chemicals that are being looked at to be regulated by the states and provinces as well as the countries around the world. And then I'm going to make the comment that I make frequently. With all the regulations, you're not going to be able to analyze your way into compliance, not by analyzing the product in a laboratory. What you have to do is you have to put a chemical management system in place so that you know what chemicals are going into your product before you manufacture it, so that you can ensure that you have a safe product and that you are not damaging the environment. The HBI program itself, we have an advantage over, first off, we are a brand. We have an advantage over many of our competitors in that we own approximately 95% of our manufacturing facilities. We manufacture most of our product. A lot of our peers, they contract virtually all of their product. Because we own our product, or manufacture most of our product, we are able to put in controls to ensure that we know what's going into our products. With regards to the chemical suppliers, we are requiring more technical chemical ingredient regulatory information than what is currently going onto safety data sheets or going onto the globally harmonized system sheets as well. To do that, we do have to enter into confidentiality agreements to protect their IP, and then there's the next tool that has not been released yet, but we're hoping it will go live within the next 2 months. The Voluntary Product Environmental Profile is a form of data sheet that will require more technical information to be disclosed by the chemical suppliers. This is going to be a huge advantage for everybody. Currently, we require our chemical suppliers to provide us this data already on a HanesBrands form, but this is a form that's going to go live, being developed by the American Apparel and Footwear Association and being offered to the community at large. For our fabric and textile suppliers, for when those occasions when we are not manufacturing product ourselves, they are under contract, they agree to comply with our chemical management programs. They may be required to provide chemical information for certain products, and we do go on site and do chemical audits to verify they're complying with our programs. We do have communication set up so that we are not just discussing restricted substances and chemicals of concern, but when we have identified what we think are safer chemical alternatives, we communicate that information to them so that they have the ability to use those same products. With regards to internal of HanesBrands, and again, this is about 95% of the product we put on the market. We have an internal dual environmental and safety approval program in place. All chemicals that go into our facility, and I highlight all chemicals, maintenance chemicals, janitorial chemicals, manufacturing chemicals, have to be approved by us before they're allowed to go in the facilities. All this data is put into a regulatory database. We do have a program in place with our research and development and product development organizations wherein they run chemicals by us for approval at top of production, meaning before a product goes into production, to make sure that the chemicals that they are looking to use are chemicals that we will approve. I've already mentioned the Voluntary Product Environmental Profile form. There is contract language, again, with the fabric and textile suppliers, requiring them to follow our chemical management system. We are doing chemical audits not only of our sourcing facilities, but our own facilities as well, and the fact that we've been controlling the chemicals going into our product, we have got to the point that we minimize product testing. The product testing that we have done has primarily just demonstrated that the chemical management is working, because those chemicals of concern that we are trying to make sure are not in our products have in fact not been showing up in any of our finished product that go to market. I'll discuss this very quickly. There are a lot of companies out there that are doing third-party chemical certifications, making claims that that if they certify your products, then it is a certification that you are in compliance with global regulations. There are none of those that we accept right now because we have found flaws in all of them. Some of them very minor, some of them very major. So if we go into audit a sourcing facility and they hold up a certificate in front of us, we say, thank you, that's really great, but it's inadequate, and we proceed to do our own internal audit to make sure what's there. So to establish a chemical management system, the first thing you've got to have is your management support. You need a documented system, in my opinion, such as this Outdoor Industry Association chemical management module that will guide you through the steps that you need to progress through in order to have a chemical management program that will carry you from the very beginnings all the way through developing a list and researching more sustainable chemistries for your manufacturing. It's imperative that you get accurate chemical information of your raw materials. MSDSs are inadequate. I'm hoping that the VPEP, when it comes out, is going to solve a lot of our issues. You need to cross-reference those MSDSs and the VPEPs with your restricted substances list, and then you need to take any action with regards to chemicals of concern. At HanesBrands, and this is a slide that has gotten a lot of attention when we've presented it. This is what we've been through. I had an executive champion the year that I started here in 1990. And I went to him and I said, this is going to be a real challenge for this company because they've never looked at chemicals before. My recommendation was the chemical approval program that I have described, wherein no chemicals can go into our manufacturing facilities without us approving them first. In this process, I evaluate chemicals to determine ecotoxicity, carcinogenicity, mutagenicity, anything that you can imagine. And we begin to evolve towards more sustainable chemistries. We've been doing this since 1991. We've worked in partnership with our chemical suppliers, throwing the challenge to them. We have identified problems with a specific chemistry. We're looking for a solution. Will you help us work towards a more sustainable chemistry? And we've made progress. So this is the evolution. It has taken time, but we have been doing this for quite a long time now. And back to the outdoor industry. The links to the chemical management module, this is it. It is free and available to all. They ask that you register for it, and it will be available for you to take a look at. I would encourage you to take a look at it, and please feel free also to comment back to the Outdoor Industry Association on any questions, comments, or recommendations you have with regards to this tool. Thank you very much.
Thank you so much, Tommy. I'm going to put up the screen with the moderating screen. So I have a couple of questions here that I will read to you that people have asked, and don't forget you can still continue to ask questions. So the first question is, the green screen is awesome. The green screen tool is awesome. The only okay, I'm trying to do two things at once here. So let's see, got to go back to the questions. Here we go. That being said, it is only as good as the material and chemical data collected from suppliers. What tools do you recommend for collecting chemical data, storing and maintaining and verifying this data? Are there any web-based tools where the supplier can enter and maintain the data and still roll it up to the manufacturer while maintaining intellectual property rights?
Okay, thank you for the question. And I think I'll ask Tommy to pick up where I leave off. Thank you. I'm glad you like the Greenscreen tool, and I agree it's only as good as the data you can collect from manufacturers and also about the chemicals. I would say that HPD is, of course, one tool you can use, and it doesn't have the infrastructure, a real deep infrastructure yet, but it does allow you to enter all ingredients in a product, and for those that are trade secret, at least it reports the associated hazards, if not the the identity of the chemical itself. So that's one option, and then you can use the HPD, and I know they're working on getting third-party verified HPDs as well. I know NSF is one of the organizations that can do that work, NSF International. Another tool that seems really good to me is the Cyvera tool. That is, they're a Greenscreen profiler also, and the Cyvera lens is based on, well, it allows you suppliers to input formulations which can get rolled up into hazard exposure and risk screens, and you can you lease access to the data in Cyvera. So that's another system that is getting us partway there. But I think you raise a really good question. I think these aren't by any means fully integrated. We haven't we're nowhere near sort of having the big SAP type supplier integration tools. I know companies like Seagate have built their own systems, but I think that's where we're heading, where you could begin to integrate. We need the data, the chemical hazard assessment data, so that can plug into the supply chain management, and those would be the two I would recommend. And maybe, Tommy, you have something else to add to that.
The one that I will offer is the VPEP form, and I apologize for the acronym. We had a meeting November of 2012 with some of the larger chemical suppliers, some of the testing laboratories, some of the certification organizations, and some manufacturers, talking about this need for more technical data. And probably after about 4 hours, I'm going to say, we came to an agreement over a form that could be used that would provide us the technical information that we needed. It includes environmental data, health hazard data, references or documentation on any chemical for which there is a restricted substance applicability. Plus, we had our own list of chemicals of concern that we felt like could be popping into the formulations of the chemicals being used in the apparel industry that were not regulated, that we wanted information on. The reporting thresholds are 0. It's not the typical material safety data sheet where if you've got a carcinogen of 0.1% or less, you're not required to report it. If you've got 0.001%, we want to know it. We're not going to accept the 0.1 and 1% rules that typically go with the material safety data sheets. So everybody agreed to that. There was already a basic form in place. It wasn't too much of an effort, but everybody agreed as to what needed to be on there. What I wasn't prepared for was what happened over lunch. We began to talk about how we're going to get this data. And I'm going to tell you that the problem with this process is this issue of transparency, because what is presented is not transparent, not in the true sense of the word. There was a need to be able to protect the intellectual property. What was finally agreed to, and when I say finally, within a matter of 2 hours, it was agreed to have a third party develop a web-based system whereby the VPEP form would be completed for chemicals, would be populated. The chemical suppliers would populate that data and they would control that data. The chemical supplier would have a domain on that application. They would control that domain and they would be able to give rights to access that data. As an example, one of the big companies we work with is DyeStar. If I go to DyeStar, and for what it's worth, I already have a confidentiality agreement in place with DyeStar. If I go to DyeStar and I say, I need access to all this chemical information for XYZ chemical, they can go to this website and they can give me access to that chemical. Or, since I already have a confidentiality agreement with them, if they so choose, they can go ahead automatically and open up their whole catalog of chemicals to my access in real time so that I can go on the web and pull down all the information that I want. What surprised me is that the chemical companies felt comfortable with this and agreed to do this. And this program is due to go live this spring. We're already requiring a lot of this data internally now for chemical companies to be able to do business with us. Our policy, once the system goes live, is that any chemical company that wants to sell us a chemical has to be a part of this program. They have to make this data available to us electronically.
Tommy, this is Lauren. I have a question. What is the name, will the name of this program be VPEP as well? And have you heard of a program called T-CHIP, which is the Textile Chemical Information Profile?
I have not heard of that. VPEP is the program. The name was developed years ago. Again, it's voluntary product environmental profile. It was started by another company a number of years ago, trying to build off of a previous program, electronic, but in those days it was CD, that was developed by the American Textile Manufacturers Association. This effort is going live hopefully this spring, and well, it will go live this spring, and it's being done by the American Apparel and Footwear Association, AAFA.
Thanks.
So our next question is, if you or a profiler completes a green screen assessment on a chemical and there is very limited data or lots of data gaps, this chemical would not be listed as a benchmark one chemical. It may turn out this chemical is extremely bad in future studies. Isn't this providing a false sense of security for your product? Also, this tool only looks at hazard and does not address exposure or risk. Is there any work on improving Greenscreen to address risk?
Okay. I think there's two questions there. One is the issue of data gaps. How do you deal with data gaps? And if you look at the guidance, which is online, you can download it, you can see that there are certain data requirements to, well, I'll back up. If you know that something is a benchmark 1 chemical, and for example, it's a known carcinogen, that would put it into the benchmark 1 category. You really, it's a benchmark 1, and assuming that those data are correct, then there's really nothing else about the assessment will make the hazard score go up. So you can be confident in that one assessment. But there is guidance that does two things. Without a minimum data set for the higher benchmarks, you can get what's called a benchmark U, which is unspecified. So you need a certain amount of data just to get a benchmark score, assuming it's not a benchmark 1 off the top. So it just basically says undetermined. There's also a mechanism whereby if you, say, meet the requirements for hazard at benchmark 3, but you only meet the requirements for data that only is at benchmark 2, then you would get a benchmark 2 with a subscript DG, meaning the benchmark score drops because of data gaps. So that's how we deal with data. And the question of risk comes up all the time, and it's a great question because the Greenscreen is a hazard assessment tool, and you have to do hazard assessment in order to do risk assessment. And so what's really nice about Greenscreen is that it lays out all the hazard information in a consistent, transparent way. And it does look at transformation products, and it would look at, say, the form of a chemical, so that you would know that, for example, if you're dealing with silica, that the crystalline form is the one that is carcinogenic, and another form might not be. So that piece is in it as well. But it really, it's really up to take that hazard information and make better decisions with it. So you can use a Greenscreen assessment I think that's a good thing because it's comprehensive. Sometimes in a risk assessment you don't really see all the hazard information summarized, and Greenscreen would do that. So I think sometimes that risk assessment and hazard assessment answer different questions, and I think every chemical should undergo risk management because, as I've been told a million times, water is hazardous. It's hazardous if you inhale enough of it. So you need to know how to manage all chemicals safely, and that's where the risk thinking comes in. But if you're choosing different alternatives based on a certain applications, then having the plain old hazard information, which takes a lot less effort than a full risk assessment, can help you make better decisions. You can look at the hazard profile and say, this is going down in the drain, but it's toxic to fish, maybe not a good choice, when something else might be a better choice. So you can look at the hazard profile and make a decision about an appropriate application, and then you can use risk management to ensure that that a chemical is going to be better too. And you might even use life cycle assessment too to think about the whole life cycle of the product. So I view it as just, it's like cost, performance, and hazard. It's each one is a module and can't really do the work of the other. And you could very well do an exposure assessment and use that to inform your decision making. So I hope that answers your question.
Okay. This one is...
Lynn, can I ask a question? This is Kathleen. I have a question for Tommy. And it relates to a particular chemical, formaldehyde. We had a situation here in Minnesota where a little girl got a really bad skin reaction from formaldehyde in leggings. And it turned out that the amount of formaldehyde in that particular product exceeded the manufacturer's standards, which was 20 parts per million. And the question that I have is, how do you assure, does the chemical management system include an audit process, and how does Haynes handle that as far as like a restricted substance and to assure that you actually meet your own standards?
Formaldehyde is regulated in the industry. The tightest standard globally is the 20 parts per million, which is probably what you're referring to for children. The tightest standard we've seen for formaldehyde for adults is 75 parts per million. Our internal standard is 50 parts per million, because we've done some of our own studies and did not feel like 75 was quite adequate. Formaldehyde is a tougher one because it is a basic building block. It can show up in chemicals even though it was not a raw material that was in the manufacturing. We do, quite often we get data that says that there's only trace impurities of formaldehyde. We don't accept that. We require them to document the parts per million of formaldehyde in their raw material. The reason for that is we've had people to come up and tell us they have trace impurities, and when you push them on it, it turns out their trace impurities are more like something in the order of 5,000 parts per million. So we don't accept that. It is challenging when you get down to 20 parts per million. We look at the chemistry, the raw material chemistry, and make sure that what is in there is below those thresholds. And for formaldehyde, this is one chemical that we do perform spot checks on to see what the concentrations are. It is extremely rare that we detect formaldehyde, and typically if we do, it's in the range of 2 to 3 parts per million. But that is one we watch closely.
I think we can squeeze in one last question, which is for Tommy, and it says, how many supplier audits do you complete for Tier 1, Tier 2, and Tier 3 suppliers?
I'm assuming you're referring to Tier 1, Tier 2, and Tier 3 finished good manufacturing. Well, yeah, let me just answer the question. Last year, if I recall correctly, we did about 30 audits that we completed for our Tier 1 suppliers. And what we do is we look at the dollar volume of business, and we prioritize based on what we are purchasing with regards to volume. Right now, we're sitting at about 98% of our Tier 1 suppliers have been audited. We have not started auditing Tier 2 right now. I would like to do that this year, but but our company has just acquired another apparel company that does not have a very progressive chemical management system formalized yet. We're going to be spending our efforts this year making sure that everything is buttoned up there, and then we're going to begin to proceed to looking at the Tier 2s, hopefully in 2015.
Thank you very much. Well, I'm afraid we've come to the end of our time for questions, and for some reason my computer is frozen and I am unable to move my slides up and down, which is unfortunate because I did want to put up a slide about the Safer Chemistry Challenge Program. So maybe Patrick can change, show my screen. Maybe Patrick can change, can change the presenter, but in any case, let me just tell you about the Safer Chemistry Challenge Program, because we're encouraging businesses to consider joining the Safer Chemistry Challenge Program, which is another Great Lakes Restoration Initiative project of the Pollution Prevention Roundtable, and that's to work with businesses to set goals to eliminate targeted chemicals that are affecting the Great Lakes. Please go to their website, which is www.p2.org, and you can click on the Safer Chemistry Challenge Program and find out more about that program. And you can also we'll also give you contact information for Cindy McComas to get more information and to join the program. It's a great program, and we really encourage you to join it. We hope that you will join us next week, February 5th, on Wednesday, for our final webinar, which will be on third-party certification, and we will be talking about cradle-to-cradle certification with Ben Bizark, and we will also have Lynn Olson from Eco Labs with us. It will start again at 1 o'clock Eastern Time, and so we hope to hear from you then, to have you join us then. I want to thank Lauren Heine and Tommy Thompson again for sharing their expertise and experience with us today. That concludes our webinar, and thank you so much for participating.